Hey team, welcome back. This is your third video lecture for PSci 232, and this one is basically, what does your computer do? How is it structured? As a preface, I want to tell you a thing that my very smart friend Rob Williams told me about the computer's file structure. A computer's file structure is basically files that contain other files, which are usually called directories, and then the actual files, right? So a Word document, or in our case, an R script. These are the actual files. And there's sort of a fun, a little bit fun, I don't know. There's a fun metaphor for directories and files. It goes like this. A directory is a box. A file is a cat. You can put a box in a box. You can put a cat in a box. You cannot put a box in a cat. Please don't try this at home. You cannot put a box in a cat. So what this means is, I'm going to open a new Finder window. Here's my Finder window. You're looking at everything that's in there's my Dropbox. There's my home folder, AAH92. And all of these files here, applications, bin, desktop, documents, downloads, etc., are directories. Within these directories are going to be, in some cases, more directories, right? And in some cases, just files. So here's my desktop. Currently, my desktop is a little bit of a mess, but it sort of serves the purpose, right? So I have within the directory called desktop, there are 1, 2, 3, 4, 5 subdirectories: Kindle, Latin Modern Roman, PSci 232 Richard, and Scatter. There are also several files. So there's an Excel file called Actor List. There's a PowerPoint on count models. Yay, we're going to talk about those later. There's another Excel file, Conf Actors. There's tickets to the Lizzo concert last week. We're going to talk about this. It was amazing. So all of those things are in the directory desktop. I want to talk to you about why it's important to have some sort of organizational system for your computer. It can be whatever organizational system works for you. So I'm just going to show you a couple. One is here in my Dropbox, and it's my academic writing, aka all my research forever directory. So Dropbox, academic writing. Within academic writing, the subdirectories are arranged by year. So here's 2005 through 11. And in that in that period of time, I was in graduate school. So you can see a whole bunch of papers, dissertation prospectus drafts, a paper about Peru, etc. After I left graduate school and got my job at Drexel, I began to organize one at a time. So 12, 13, 13, 14, etc. And within my yearly folders, everything is arranged by project, except for occasional stray files that I haven't filed yet. So here's this year. This year I'm working on the Armed Group Institutions database. I'm working on a simulation project involving battle deaths, and so on. Okay, so that's one possible way of organizing your so-called directory structure. Another way is here in my Git folder. Some of you will have heard of GitHub. Some of you will not. It's not a big deal. We're not going to use it. But GitHub and the associated files are how I share work with colleagues not at Drexel. So here's Git. Here are my 3 projects that are currently going in Git. Here's SV, which stands for El Salvador. And within SV, I have things organized by the sort of type of task. So here are data cleaning tasks. Here are tasks where I compare 2 or more data sets. Here are tasks where I analyze individual data sets. Here are tasks where I match across data sets, and so on. Then within each, let's go back to clean. Within each task, there's Within each task type, there are individual tasks. So the one that I've highlighted right now, perp vial, is me canonicalizing. That's a word we're going to learn in a minute, but not this week. Me canonicalizing the names of perpetrators and types of violence in the case of El Salvador. And within each individual task, there are usually 3 folders. Input is where the data comes in, usually from another task. Source is the code that I've written. You'll see a .r file here. And then output is where the analysis goes. In our class, you will want to have a PSI 232 folder, maybe on your desktop. That's usually convenient. You can see that I have one here with 2 random PDFs in it. Those don't belong there. I'm going to put them in the trash. It's currently empty. And the difference between what we'll do in PSI 232 and what I do in my sort of Git organization with colleagues at the Human Rights Data Analysis Group is that we will probably end up keeping data, code, and output in the same folder, in this PSI 232 folder. So if you don't have a PSI 232 folder yet, I'd like you to take this moment to go ahead and create one. You can pause the video. Okay, great, you're back, you've done that. So what I want to do now is to look at the ways in which we can sort of figure out where we are when we're using RStudio. So I'm going to open RStudio. You should do that too. Come on, RStudio. This is a weird bug. You'll see I get this almost every time lately. I'm not sure what's up with it. It doesn't stop my RStudio install from working, so I'm just not going to worry about it. So here we have RStudio. I clicked out of the script window, which is usually at the top left. So we're just going to work in the console for the moment. And what I'd like you to do first is to type get wd, open parens, close parens. Getwd is a function. It is installed with R, it is basic to R, and it means get working directory, which is to say, tell me where R will look for files by default. So when I hit return, I find out that my working directory is /users/aah92/desktop/PSI232. Now, the slashes mean going down a level. So my top level folder is called users. Within the users folder, we're going to look in the AAH92 directory. Within that, we'll look on the desktop. Within that, we'll look in PSI232. And the reason that that's important is that that is where R will look for data and code that you have saved. So the first thing that you need to make sure that you've done is you've already created a PSI232 folder, but I think it's going to be useful to you now to set that folder as your default working directory, which is to say, when you open RStudio, it will always default to looking in that folder for whatever it needs. So to do that, up on the very top, you're going to go RStudio, click on Preferences, and here you can see that mine is already set to PSI232 as the default. So under the General pane, you're going to browse to wherever your PSI232 folder is kept. So for example, if I were to do that, click Browse. I know that mine is on my desktop, but I also know that my desktop is within my home folder, which is AAH92, desktop, PSI232. You're going to click Open, and then click OK. All right. So congratulations, getwd is the first function you're going to use. Now, if you wanted to set the working directory you would use setWD. I know, it's amazing. So let's say for the moment that I wanted to switch my working directory to the desktop. Now what I would do is use the function setWD. Unlike getWD, setWD takes an argument, which means you have to put something inside the parentheses. We're going to use quotation marks because we're looking for a file location, not for an object. And we're going to say, so I'm going to use a piece of computer syntax, and I want you to learn this. I'm going to go ... dash. And when I say ... dash, that means go up one level. So if I'm in PSci 232 now, I want to go up one level. And when I go up one level, I'll be on the desktop. Okay, so ... dash has taken me back up one level to the desktop. And let's check. Think about how you would check that. You would do getWD again. This is, again, a function that takes no arguments. And yes, there I am. But let me go back to where I want to be. I will do setWD, quotation marks. It doesn't matter whether you use single or double quotation marks. And because I'm on the desktop and I know that PSci 232 is on the desktop, I'm going to start typing PSC, and then I can hit Tab, and it will autocomplete. That is your friend. This is such an important thing to know. Autocomplete is your friend because R does not have spell check, but it does care about spelling. All right, we're back. Great. So we are going to look at one other thing in the context of our How Your Computer is Structured lesson, and that is, let's talk about giving values to variables in R. So I'd like you to type your name. Just type your name, no quotation marks. There's mine, Amelia. Now, you too, unless you have a name like getWD, should have an error message that says object Amelia not found. That's because when something is without quotation marks, it is referencing an R object. An R object can be a data set, it can be a variable, it can be a string of numbers, but you have to give it a value. So let's do that. Amelia, and the way you give something a value is to go less than hyphen, and the way we usually pronounce that is gets. So Amelia gets, well, let's say that the variable Amelia should take the value, quote, Amelia. See, it shows up in your environment. That's nice. You now definitely have an object in there. Try typing it again, Amelia. Now it returns the value of the object. Okay, so right now Amelia is a variable with a single value, and you can do a lot of stuff with that. For example, this is what's called a string variable or a character variable because it is just a word. One thing that you can't do is do math with string variables, right? So if you try to take your name plus 1, you're going to get an error. And I'd like you to keep track of errors. Errors are scary. Everybody hates them, but they are really important. And everybody gets them all the time. There's no problem with getting them. I get them constantly in my day-to-day work over 15 years of working with RStudio. So if you get an error message and you don't understand it, screenshot it, Google it, send it to me, because error messages at some point will become your friends, I promise. Okay, so we have, we have assigned our first value to a variable. And that is as far as we are going to go today. We're going to talk more in class about what it means to assign values to variables, what kinds of values variables can take, and what other objects R can sort of recognize and deal with. But that's all for right now. I will see you in class.